Hey, welcome back. And this is called maximum depth of a binary tree. So in this question, it's an easy level kind of binary tree method where we want to traverse this tree and find out its max depth. And so what that means, and I'll quickly grab my pen, is the root node we're going to first set to a depth of 1. Often I think it's a depth of 0, but in this case they're dealing with it being 1. And so as we go down this tree, we're going to be incrementing our depth. And so at this level, it's going to be a depth of 2, not 1, 2. And then as we go down further, it would be a depth of 3. And so that's because with each kind of node that we're adding, we're just adding 1. And we're adding 1. Okay, so in this case, we would have a depth of 3, and that's why we return 3 in this case. And in this case, it's 1 null 2, so that would look like this, where it's essentially, this is empty, so there's no node on the left side. So it's just like a 2-node tree. So this would have a depth of 2 because, well, we count 1 for the root node, and we count 2 for its child. Okay, so if that doesn't make much sense, I think it will make a little bit more sense once we get to it. So the code itself takes very little implementation. We're going to make it a one-line solution, but initially I'll just kind of expand it so it makes a bit more sense. So the first check that we want to do is check if our node is null, and if it is, we're just going to return 0. And so that accounts for the case, the simplest case at least, where what if we just passed nothing, like we passed a null tree, so the tree doesn't even exist. And so in that case, we'll just want to return it has a depth of 0. So otherwise, what we're going to do is just in this one return statement, we're going to do 3 things. The first thing is we're going to add a 1. And so this means, and what this is doing, is with each, and we're using recursion, so with each call to this max depth, we're going to add 1. And so what that's doing is, as we go down this tree, with each kind of iteration downwards, we're going to add 1. So down here, we're going to add 1, and so forth. So that's what that's doing. Now the next thing that we're going to do is we're going to take the max of the left and right side. So we'll call our method here, and we'll take the left side, and then we'll take the right side. So just copy it over. And so I'm just going to run this, and just to show you that it works, and then I'll explain, what this logic is doing in a second. Just run it and submit, and success. So what this is doing is we're comparing the left and right side. And so that's doing is we start at 1 here, and then traverses the left and right. And so in the left branch, it would add 1 here, and it's going to add 1 here. And so then once we get to this, say we're on this side, it's going to go left and right here. And it's going to say, okay, this node is null, and so it's going to return 0. So this returns 0, and this returns 0. Let's look at on the right branch. So these traverse to the left and right. So this returns 1, and this returns 1. And when we go past this node, it's going to return 0, and 0, and same with this node. Just for the sake of showing it, I'm just going to write it all out. And so now what we're going to do is, as we're kind of backtracking to the top of the tree, merging the results together, it's going to go upwards now. And so what we're going to see is we're going to compare the left and right for this tree and go, okay, the max of the left and right are just 0, so it's going to return 0. And so 1 here, right? 1 plus that is just 0. So, or 1 plus 0 is 1, sorry. So it's going to return up here 1. On this side of things, same thing here. Left and right comparison, okay, the max is just 0, so it's 1 plus 0 in this case, which will be 1. And so it's returning 1 up here. And so in this case, same thing. The max of its left and right children are 0. So it's 1 plus 0, and it's returning 1. And so now, in this case, it's going to return 1, or compare its left and right children, which are 1 and 1. And it's just going to do the max of it, which is, well, 1 and 1 are the same, so the max is 1. And so now we're going to add 1 to it, so 1 plus the max, which is 1 in this case. And that equals 2, so 2 is going to go up here. And on this side, remember, it was 1. So now at the very root level, it's going to compare its left and its right children. It's going to say, okay, what's the max? In this case, 2 is greater than 1, so it returns 2. And then 1 plus 2 equals 3. And so that's essentially how it works. So just to show you how we can actually do this in one line, what you do is you just say, actually, I'll just collapse it down. I'll show you. So if node is null, then we return 0. Otherwise, return this statement here. So I forget what that's called. I just usually call it like the simple if-else statement, but it's essentially a one-line solution. So yeah, I hope that helped, and good luck with the rest of your algorithms. Thanks.